Hello everyone, welcome to our Python lab, Python classroom. I'm glad you're watching the lessons. Today we continue talking about functions because functions are super important in software development. And we are going to talk not only how to pass data into function, but how to pass data the other way around, from the function to the calling function. Sometimes it's useful to take a look at your functions in your application from parent-child point of view. Sometimes it's useful to look at this relationship as parent-child relationship. So the function which is calling, we may call parent, and the function which is being called, we may call a child. Please don't forget, before we continue, to support the channel by your likes, by your views. So let's do it. Let's talk now about this kind of relationship. Look at the arrow below. If my child allowed to talk back, because using arguments and parameters, you allow parent to talk to the child, to pass information. But is it possible the other way around? Yes, it is. You can also pass data from the child to the parent. And you did it through return statement. In the previous lesson, we learned return statement may just interrupt the function, but if you provide for return parameter, you may also return some data back to the calling or parent function. So an example, as usual, very simple. I develop super simple function. I call it average. It accepts two parameters and it calculates the average of two numbers. In order to achieve that, I created extra variables. So first I calculated the sum. By the way, let's make it more consistent, because usually we use capitals to separate the words in our course. So let's make it more consistent. And then I'm gonna run it. So what's happening here is a function. I calculate in line number 2 the sum. I save it in a temporary variable. Then I calculate in line number 3 the average. I save it in line 3 in a temporary variable average. And then my application, my program, or my main script starts here in line 6. I call average and I print the result. I pass to average 5 and 3.5. Also, we are going to discuss after I test it, after I make sure it's working, we are going to test very important point. Two types of variables in programming: local variables and global variables. But first, let's save the changes. Let's run it. And yes, you see it's working. I see first the so let me change here also the name of the variable accordingly our style. So first I call it with 5 and 3.5. Then I call it with 1967. So I see two different results, two different prints. Let me show you again what's happening. And you see that's the first average, 4.25. That's the second average, 79, because that's the average of those two numbers, 90 and 67. Okay, now, what is a local and what is a global variable? Local variables defined inside the body of the function. You see I define two local variables in line 2 and 3 just to achieve whatever task you may declare as many local variables as you need. But the very important thing is they have limited time life. So the memory for those variables allocated at the beginning of the function, and then they are basically removed from the memory. They don't exist after function finished. And of course, you see here a new return statement format. So you may not only return, you may also return some information back to your calling function. In my case, calling function is the main script. So if it happens, if your function returns something, it should be used on the right side of the assignment. So you call it, you save the result somewhere, or you may use it in expressions. Average now can be used in expression like print. So what's the global? Global variables, they defined outside of any function, and they have much longer life, like Mark 1 and Mark 2. They exist for as long as your program working. But local variables, they exist only for as long as a function is working. So if you, let's say, call average 10 times, then you're gonna create local variables sum and average 10 times, and you're gonna kill them 10 times when function returns. They are released, they are disposed, they removed from the RAM. That's why it doesn't make any sense to try to address or access them from the outside of the function. So that's the rule of the thumb. Never try to change to access to read local variables from outside of the function. In real life, it's not enough to divide your application into set of functions. That's nice, of course, it's very good. But complex or real-life apps may take a few hundred or a few thousand of lines. Imagine if you keep all the functions in the same file, which is possible, how long your main script going to be. Much better idea is to separate functions, to place them into new files. So this way you not only logically divide your application by using functions, but you also physically divide your application by creating many source files. We call this source file with a bunch of functions or just with one function. We call it module, and module are super important. You need them all the time in order to keep your project organized. You have to separate. And again, I'm gonna show you very simple example how the module could be created. So let's say I have a bunch of functions to help me do some mathematics. Of course, those examples, they are just made up for simplicity. However, it doesn't matter right now. I wanted to make it as short as it's possible. So let's say I have function to add, I created function to multiply, I created function to do average, and then the important step, I don't put them in my main file. I put them into a separate file. I call it helpers with the same extension py, and I can use now all of them. So let's take a look. How would I use my three functions? Just by using directive import. So by using import directive or command, you connect everything from that file to your main script. Let me run it. Let me show it's working. Yes, you see the addition, the product, the average of two numbers. However, if you think it's too boring to keep typing prefix helpers, if you use those functions a lot, you may do this way. From helpers, import everything. Asterisk usually means everything, and then you may make it a little bit shorter. So let's try another way to connect module to your project, and you see the result is precisely the same as it was before. So basically we covered everything related to functions, how to define functions, how to call them, how they can be related, parameters, arguments, returned values, and variables created inside functions, very important, local variables, how long they live. Variables created outside of the functions, global variables. So the interesting observation is, let's wait a little bit, ambulance. So the interesting observation is, of course, a lot of functions a lot of functions already created for you. We call them library functions, and you can see print, for example. It's something which is already done. Some good programmers, good people from Python framework, from Python society, they did it for you, and you don't really have to worry about it. So there is plenty of library functions, and you just need to read documentation, how to use print. You can open documentation at python.org. Python.org has a lot of help documentation, and you use them. So you don't define those functions, you just enjoy using them. Sometimes they are grouped into modules, and in order to use some library functions, you have to do import command. But some of them, like print, they automatically connect it to any project, so you don't even have to bother with the import. If library function is library function, sorry for the interruption, now it's a fire truck. So if library function belongs to certain module, then you use import, and you can call them with the prefix or without prefix, the way I showed you. There is also a very interesting type of functions, and we call them event handlers. We don't use them yet because we just doing very simple console exercises, a few lines programs. We don't need event handlers. However, as soon as you start developing real life apps, website, desktop applications, as soon as you start using widgets, elements users supposed to manipulate, you're going to need event handlers. Event handlers, it's a special function to react on certain events in the system. For example, there is a button the user may click, or there is a text field in your app where the user may type. You have to, of course, anticipate as a programmer such events, and you have to react on them. And we call those special functions event handlers. We are going to try them. We are going to learn them in this soon, very soon, when we start covering object-oriented programming. But for now, let me show you like a very simple classification. So here in my textbook, I divide all the functions into 3 types or 3 groups. And let me scroll. So let's say normal functions defined by you and called by you. You do both. You define them, you call them. Library functions, they prepared already, so they defined by somebody. I call it somebody, it's the programmer or programmers who created Python framework. But you call them, you use them. And finally, event handler defined by you. You write the code for the event handler, but you never call it. Operating system going to call those functions whenever certain events happen. For example, whenever somebody clicks on that button, you have to react, you have to prepare some coding to handle those clicks. So I think this table is quite interesting. It shows you three types of functions, and we are going to try and cover event handlers when we cover object-oriented programming. It's gonna happen very soon. Just follow my lessons. Maybe in a week we finish all the essentials and we start doing more advanced programming, which is called OOP, object-oriented programming. Thank you very much for listening. All the best. Bye-bye.